This video discusses the runs test that can be used to analyze patterns and control charts that may be worth investigating as we embed these control charts and the processes in a continuous improvement program. Here we have the mean chart that was developed in the last video for the 20 samples of 5 steaks that were taken and measured by the butcher for weight. We don't see any points outside the control limits, but it would be interesting to know if this variation that we do see could be considered purely random, or if there are changes in the data over time that might constitute patterns. First, we'll perform the runs test for points above and below the center line. The center line is the red line on the control chart. What we do is we count groups of points that are consecutively appear on either side of the center line. So as we start, the first point that we see is all by itself below the center line. So we'll count that as run number 1. A run can just be 1 point. The points then move above the center line. So this will be run number 2. And then again, we cross the center line and we have a group of 4 points below the center line. So this group of 4 points together will be run number 3. So far we're counting runs, we have 1, 2, and 3. Here we have a group of 2 above the center line, that's 4. 1 below the center line, that's 5. 3 above the center line, that's 6. 2 below the center line, that's 7. 1 above, 8. 3 below the center line, that's 9. 1 above the center line, which is 10. And 1 below the center line, which is 11. So we have 11 runs above and below the center line. Sometimes we see points like this one that the arrow is indicating that are very close to the center line, and sometimes it's not obvious on the chart on which side of the center line they fall. In that case, we might have to actually go back into the data and see which side of the center line that point is on. So we have 11 runs. I have a table here to record the number of runs. We also need the mean and standard deviation for runs above and below the center line. These are provided on the table posted with this week's lesson. We have 20 samples in this data set. So if I go over to this tab called Runs Charts Table, find 20 as the number of samples, and then find the mean and standard deviation, I'm going to focus in on this row. The mean is 11 and the standard deviation is 2.18. It means that, on average, if we have a control chart with 20 samples, we would expect to see, as a long-run average, 11 runs above and below the center line, with a standard deviation of 2.18. It just so happens that this time the number of runs we have is exactly at the mean, which will not always happen. The z-score in this case would be the number of runs minus the mean divided by the standard deviation. This formula is shown in the last page of this week's lecture. Because the number of runs is equal to the mean, the z-score is 0. But this will clearly not always happen. This runs test will be the same whether we're doing a mean chart, a range chart, a p-control chart, or a c-control chart. The same runs test can be performed on all types of control charts. The thing we have to keep in mind is that The mean and standard deviation will change with the number of samples. Let's look at the runs test for points up and down on the control chart. We need to count consecutive points that are moving in one direction. So if we start with the first one, at least the first 2 points will always be part of the same run. So here's a run of 2 points going up, that's number 1. Here's 1 point going down, that's number 2. 1 point going up is run number 3. Again, runs can be 1 point or multiple points. Here we're ignoring the center line. We're just finding the points where the line changes direction. So far we have 1, 2, 3, 4, and then here is a run of 2 points going down, which is 5. A run of 2 points going up is 6. 1 going down is 7. 3 going up is 8. 2 going down is 9. 10, 11, 12, 13. So we have 13 runs up and down on this control chart. Again, I need to go to the run charts table and find the mean and standard deviation. We have 20 samples, and the up and down mean is 13, and the up and down standard deviation is 1.8. So again, the z-score is the number of runs minus the mean divided by the standard deviation. Again, we have a z-score of 0. Let's look a little bit more quickly at the range chart. And then we'll talk about the rule for evaluating the z-scores. On the range chart, in terms of runs above and below the center line, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The mean and standard deviation are still again 11 and 2.18. In terms of runs up and down, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The mean is again 13 and 1.8. The z-scores are the number of runs minus the mean divided by the standard deviation. The number of runs minus the mean divided by the standard deviation. Our rule for evaluating runs tests and the z-scores that are associated with them is that if the z-score is less than -2 or the z-score is greater than 2, then we conclude there is non-random variation. So in all these cases, we would classify the variation that we see as random. So in this case, our runs test don't reveal any patterns that would tend to be unusual for a process that is centered consistently and has consistent variability. If we did see z-scores less than -2 or greater than 2, it might indicate a pattern of points moving in one direction, or points that are sometimes above the average followed by others below the average that indicate patterns in the data that might result from somebody intervening in the process. And we would want to investigate these as part of a continuous improvement process and hopefully improve the consistency of the process over time by doing so.